हेलो फ्रेंड्स, स्वागत है आपका हमारे यूट्यूब चैनल पे। तो जैसे कि हमारी एक सीरीज चल रही है, क्रैक आईआईटी। So here we are discussing the mathematics chapters. In the mathematics chapters, we are discussing the limit chapters. So 2 days back, I have started the limit chapters, and we have completed some portions like what is the mean of the limits, where we can use the concept of the limits, and what is the existence of the limits, how to find the its LHL and RHL. Some of the functions will be not defined at the particular value, but it is defined at its neighborhood value. So for that we find the value for the LHL and RHL. Okay. So also we have seen how to find the limits by using the different types of the methods. First one, it was the substitutions method, or rationalizations method, and factorizations method. So in this today class, we will see about the master of the limits, that is the L hospital rule. L hospital rule will be used in most of the limit questions. Wherever the limits will be not able to find out, we will find it by the L hospital rule. In the L hospital rule, what we will do, how to find the limits, in this class we will study about this one. So let me share the screen first. So I think my screen is visible to all. Hmm. So in the today class, we will study about the L hospital rule. L L hospital rule. So what's the this rule states that if there will be two functions will be given, if the limit will be given in the terms of f dash x tends to a fx divided by gx, and it is in the form of either will be in the form of 0 by 0 or infinity by infinity. So if the limit will be given in the forms of the numerators and denominators, and after substituting the value of x tends to a, the limits gives the value of 0 by 0 or infinity by infinity, then its value will be equal to limit x tends to a fx upon gx will be equal to limit x approaches to a and f dash x divided by g dash x, means this limit value will be equal to the differentiation of the numerators and denominators separately. So in this case, in L hospital rule, we actually what we do, we differentiate the function, differentiate the numerators and denominators separately until the indeterminate form indeter that is the 0 by 0 or infinity by infinity will remove. So we will differentiate the numerators and denominators separately until we will be free from the indeterminate form. That is the 0 by 0 and infinity by infinity. It is the indeterminate form. So we will see the examples based on this one, L hospital rule. Mostly questions we will apply the L hospital rule. So there is a questions limit This is theta tends to 0, theta minus sine theta divided by theta q. What is the value? So here if you substitute the value of theta is equal to 0, so it will be in the form of 0 0 minus sine 0 0 0 by 0 form. So we will apply L hospital rule. L hospital rule. So we will differentiate the numerators and denominators separately. So we will differentiate the numerators differentiation with respect to theta. So d theta by d theta, differentiation of theta with respect to theta, it will be 1. And differentiation of sine theta will be cos theta upon differentiation of theta q, it will be 3 theta square. Again we will check it is coming in independent of the indeterminate form or not. So if you substitute the value theta is equal to 0, so 1 minus cos 0 will be 1, so 1 minus 1 0, and denominators will be also 0. So it is again it is in the form of 0 by 0 form. So again apply L hospital, LH rule. So again we will differentiate the functions, the numerators and denominators separately. So 1 minus cos theta, so differentiation of the constant term, that is 0, and differentiation of cos theta with respect to theta, it will be minus sine theta, so it will become sine theta, upon differentiation of 3 theta square, it will be 6 theta. So we will check after substituting the value theta is equal to 0, sine 0 0, again it will come in the 0 by 0. So again we will apply LH rule. We have to differentiate the functions numerators and denominators separately until it will be in the independent of the theta. So numerators differentiation will be cos theta, and denominators differentiation will be 6. So we will substitute the value cos theta cos 0 will be 1 and 1 by 6. So this will be the final answer. So we can find the limit problems by using the L hospital rule. Okay. Now the second questions we will see. Limit x tends to pi by 2 tan x into log of e sin x. So we will try to convert it into the numerators and denominators form. So this functions can be written as limit. This can be written as tan x can be written as, this will be in the numerators, and tan x can be written as 1 by cot theta. So cot x. Now we will substitute the value limit x tends to pi by 2. At x tends to pi by 2 sin pi by 2, it is 1, and log 1 will be minus infinity. So and cot pi by 2, it is infinity. So log 1 will be 0, and cot pi by 2, it is also 0. So this is in the form of 0 by 0 form. So we will differentiate the functions limit x tends to pi by 2 log differentiation of the numerators log x, that is the 1 by sin x, and differentiation of, again using the chain rule, the differentiation of sin x will be cos x, and differentiation of cot x is cosec square x. Now we will see it will be equal to, we will rearrange the functions. Limit x tends to pi by 2 cos x by sin x, cos x by sin x, and minus 1 by sin square x, 1 by sin square x. So sin square x will be go upside, so it will be equal to limit x tends to pi by 2, sin x will be cancelled, so minus cos x into sin x. So we will substitute the value for sin pi by 2. So cos pi by 2, it will be 0, and sin pi by 2, it will be 1. So its value will be 0. This will be the final answer. Okay. So now we will see the use of logarithm term. by solving the limit problem. So how we can use the logarithm term whenever the functions will be given in the terms of okay. So wherever the functions will be given in the terms of the exponential term, exponential function. So there we can use the concept of the logarithm. Logarithm, how we can take if the functions will be given a to the power y is equal to x. So it can be written as y is equal to log base a of x. This is the convergence from the exponential to logarithm. Okay, so in that case, if the limit terms will be given in the terms of exponential, means something to the power something. So in that case, we will take the logarithm concepts, and in the logarithm concepts, if it is given base a and m to the power n, m to the power n, so n will become outside log a m. This is the properties of the logarithm. So directly we can come on the problems. So one problem is given x tends to 0 plus sin x whole to the power sin x. So this is in the form of, you can see if you substitute the value of x tends to 0. So sin 0, 0, 0 to the power 0 form. So this is in the form of indeterminate form. So what we will do, we will assume this functions as a y. Y is equal to sin x whole to the power sin x. Now taking logarithm both sides. Taking logarithm both sides. So if I take the logarithm both sides, so it will become log y, and this one will become log of sin x to the power sin x. So we will use the properties. We will use the properties of the logarithm. So sin x will become outside, sin x into log of sin x. So this one can be written as log of sin x divided by sin x can be written as cosec x. Cosec x. So now we will find the value for the limit. We can put the limit in both the sides. So limit was given x tends to 0 plus log y. Log y will be equal to limit x tends to 0 log of sin x divided by cosec x. So if we put the value of 0, so it will be in the form of log sin 0. Sin 0 will be 0. So log 0 will be infinity minus infinity, and cosec 0. Cosec 0 will be, it will be infinity. So this will be in the form of infinity by infinity. So we will apply LH rule. So we will apply the LH rule. So limit, we will differentiate the numerators and denominators separately. So differentiation of the numerators will be log x, its differentiation will be 1 by sin x, and sin x differentiation using the chain rule, it is the cos x, and different denominators, in the denominators cosec x, its differentiation will be cosec x into cot x. So we will simplify the term limit x tends to 0 plus cosec x, it will be this one 1 by sin x, it will be cosec x. So this one will be get cancelled, cosec x into cos x divided by this one will be minus cosec x, and cot x can be written as cos x by sin x. This one will get cancelled and cos x will get cancelled. So this one the term will comes in the terms of limit 0 plus, and sin x will become upside. So sin x, so sin x, sin 0, its value will be 0. So the log of y, the log of y will be equal to 0. So here we can assume any of the value as the base. So we have assumed the base is e. So y will be equal to e to the power 0. So y will be equal to 1. Okay. So this type of the questions, it can be solved by using the logarithmic if the functions will be given in the terms of exponential. Okay. Now we will see one type, a new type of the question. This is the another type, that is the limit is given x tends to -1 and x cube minus 2x minus 1 upon x to the power 5 minus 2x minus 1. So if you substitute the value of -1 in this limit function, its value will be -1 and +2. -1 plus 2, -1. -1 and +2. -1 and +2, it will be +1. So +1 -1, 0. It will come in the form of 0 by 0 form. So we will apply LH rule, L hospital rule. So according to L hospital rule, these functions will be equal to differentiation of the numerators and denominators separately. So the differentiation of the numerators will be 3x square minus 2, and in the denominators, differentiation of denominators will be 5x to the power 4 minus 2. Now we will substitute the value at x is equal to -1. So 3 into -1, 3 minus 2, it will be 1 upon x tends to -1. So 5 minus 2, 3. So since it is not coming in the 0 by 0 or infinity by infinity term, so at only the one step, its value has been came. So we can write down this is the final value for this limit. Okay. There is very good question. The question is the sum to infinity of the series. This type of the questions generally we see in the IIT examinations. Okay. 3 by 1 cube plus 5 by 1 cube plus 2 cube plus 7 by 1 cube plus 2 cube plus 3 cube up to infinity. Okay. So here we can see it is the sum of the infinity term. So wherever the terms will be given in some sequence, so we will find its TR term, the general term. And we can take the summation of the TR term. So TR, any of the terms can be taken as, it can be TR, any of the middle term or any of the terms, TR general term can be written as, you can see the pattern of the numerators. It is in the 3, 5, 7, means it is the odd term. So odd term can be written as 2n plus 1. 2n plus 1, and denominators, it can be the sum of the cubes of the natural number. So it can be 1 cube plus 2 cube plus 3 cube up to r cube. Okay. So this is the 2n plus 1. Numerators will be 2n plus 1, and in the denominators, it is the sum of the cubes of the natural terms up to r terms. So we know the formula for sigma r cube. It will be the r into r plus 1 divided by 2 and whole square. So we will use the formula for this one, r into r plus 1 by 2 whole square. So we will simplify this term, 2n plus 1 into 4 upon r into r plus 1. So summations will be written up to n term, that is the summation of TR term, TR. So TR term, r will be equal to, r is equal to 0 to 1 to n, and n is up to infinity. So if we put the r is equal to 1, so it will be 3. Okay. So summation of n, r is equal to 1. TR term is given. We can take 4 outside. So 2n plus 1 divided by r into r plus 1. This is the term of the TR. So, and this one will be the square, because here it is the square. This is the square, r square and r plus 1 whole square. So using the partial fractions, we can write this term will be in the terms of the difference of the two terms. How we can write? We can write 1 upon r square minus 1 by r plus 1 whole square. If we write in this type, we can see here, if we, it is up to r, not n. All over it is the r term, because we have taken the term of r. Okay, so up to r is equal to 1 to n we can write. Okay, so here if we take the LCM of this one, so r plus r square plus 1 plus 2r and minus r square cancel, so it will be 2r plus 1. This is 2r plus 1. Okay, so this one term can be written as summation of r is equal to 1 to n 1 by r square minus 1 by r plus 1 whole square. So we can expand this term 4 into, if you substitute the value of r is equal to 1, so it will be 1 minus 1 by r is equal to 1, 2 square. Okay, plus the second term will be 1 by 2 square minus 1 by 3 square, plus third term will be 1 by 3 square minus 1 by 4 square, up to, it will go up to 1 by r square minus 1 by r plus 1 whole square. Okay, so here we can see that this term will be get cancelled, because this value will be as the 1 positive 1 negative, so this term will be also get cancelled. So what are the remaining term? Remaining term will be 1 minus 1 by r plus 1 whole square. And this sigma is r is equal to, it is the sigma is r is equal to 1 to infinity. So if you put the r is equal to infinity, so the denominator terms will be infinity square, so it will be also infinity. So this value will be 4 into 1 minus 0, it will be equal to 4. Okay, so in the today class we have studied about the, it's a very useful terms, that is the about the L hospital rule. So generally the questions will be, any of the limit problems can be solved by L hospital rule. In that case, actually we differentiate the functions, numerators and denominators separately, and also we have seen the two examples, and we have seen for solving the limit problem by using the logarithmic, if the functions will be given in the terms of the exponential. So we will take the logarithm both side, and we will solve the limit problems by applying the, if it is requires to apply the L hospital rule, we can apply. Okay, and here it is a very good type of the questions, that is the IIT questions. It has been asked before. This type of the questions, generally there are so many times of this type of the questions has been asked in the IIT examinations. Okay, so in that case, first of all, in the summations case, generally we will first find the its general term, and we will take its summations of the terms from r is equal to 1 to because the terms it is given up to infinity, so infinity. Then after we will solve like this way. Okay, so so we have stopped the sharing my screen. So already we have studied for half an hour, so for today it's enough. So tomorrow I will see the some basic expansions of the limits. Then after we will see some properties like Leibniz rule and sandwich theorem in the limits problem. Okay, so आज के लिए बस इतना ही. तो मिलते हैं अगली क्लास में, यानी कल की क्लास में, इसी टाइम पे, इसी वक्त पे, लिमिट प्रॉब्लम के साथ. तो तब तक के लिए गुड बाय, शुभ रात्रि. मिलते हैं कल. ओके, बाय बाय.